Hello friends, welcome to follow up. In this video, let's have a look at problem 1046, last stone weight. This is today's daily challenge problem. In this video, we're going to explain a solution based on the use of a heap. So we are given an array of integers called stones, where stones I is the weight of the ith stone. We are playing a game with the stones, and on each turn we choose the heaviest two stones and smash them together. Suppose the heaviest two stones have weights x and y respectively, and we can assume that x is less than or equal to y. Then the result of this smash is the following. If the two stones have exactly the same weights, then both stones are destroyed. Otherwise, x is slightly lighter than y. So the stone of weight I is destroyed, and the stone of weight y has new weight, that is y minus x, right? The larger minus the smaller one. Or you can understand this second item as that. So if the two stones have different weights, so we just need to get the absolute value of their difference, right? So actually even the first one, because if we compute the absolute value, it's 0, right? So at the end of the game, there is at most one stone left. So we want to return the weight of the last remaining stone. Otherwise, if there are no stones, we just need to return 0. So here are two examples. Example 2 is very special. It's sort of a special state, right? So in this stone, it contains only one stone, so we just return the weight itself. So in the first example, the output is also 1, but with a different procedure, right? So if you can see, the heaviest two are 7 and 8. After you smash that, you get a 1, right? So you get 2, 4, and 1, 1, 1. So in this case, so the length of the stone is decremented by 1, right? Now we have 2 and 4, right? So then we smash them, and then we get a 2. So we have 2, 1, and 3 ones, and two more ones. In total, 3 ones. And then the two heaviest are 2 and 1. So we smash them, so we get a 1. So now we have 3 ones. And then this is the different, slightly different operation, because this x and y are the same now. So we have 1, 1. So we smash the 2, and then both the 2 disappear, and then the length of the stones is decremented by 2. So now we have a 1, same as the state in example 2. We just need to return this one. However, the generic case also have this situation that we have 0 stones. So this kind of example is easy to devise. Here, let me give you one. So it's very easy to do it. So for example, you have 2 and 2, right? So the same, and then you smash them, you get 0 stones, right? In this case, you can return 0. So this is just one scenario, right? So before we look at the coding part, let's also look at the constraints. So typically, we regard the constraints as additional assumptions. Like here, we have 2 additional constraints. The first one is on the list length. So the length is bounded below by 1. In other words, the stones at a list is not empty at the very beginning. And its length is bounded by 30. So basically, it's a very short one. And the second one is on the stones weights, right? So they are bounded below by 1, in other words, positive, and bounded above by 1000. So this one, basically only we get the information that these stones are positive in weights. That should be sufficient. That should be sufficient. So as for the coding, actually we can, here the data structure or data type. So we are going to use is heap. So we're going to, actually we need to use max heap, but here in Python we have implementation that is min heap. So we are going to use min heap. So here basically it's just flipping the sign, right? With that said, basically we are ready to do the coding. So here I'm demonstrating one way just to digest the process. So essentially it's a simulation idea, right? So let's see, use a simulation with heap. So here specifically I'm using min heap. So for this, first I'm going to get the negative stones. So here actually I use some extra space, but I notice that the length is not very long, so we should be okay, right? So we net negative weight for weight in stones. Just flip the signs, and then we're going to first want to heapify this guy, this neg stones, right? And then we're going to mimic the process. So well, length of neg stones is greater than or equal to 2. In other words, strictly larger than 1, right? And then we are going to make 2 pop operations. So heap q, heap pop. So here actually we pop from neg stones. Let's do it again, right? Let's modify this x to be y. So notice that x and y are negative, and actually it's they are the 2 largest in absolute value. In other words, x and y correspond to the 2 heaviest stones. Then we can examine the scenario, right? If x equals y, for sure negative x also equals negative y. And in this case, we just continue, right? Otherwise, they are not the same. So then, after smash, the weight left actually is nothing but x minus 1. We don't care about which minus which, but we just need to know they have absolute value. This is the result, right? So we want to heap push this weight to the next stones, right? So here I want to put a negative sign, right? Because in the next stones heap, so we are storing the negative weights, so we make a negative absolute value. So this way actually we finish the procedure. So next we just need to check if we have stones left or not. So if neg stones, so in this case, because we just exit the while loop, so the length should be 1. So we just need to return neg stones 0. So this is a negative thing, so we put a negative sign in front. And otherwise, we just need to return 0. So you can directly return 0 or just, if you like, to make the logic more hierarchical, so we can return 0 like this. So this actually forms a solution format to this problem. So you can actually adjust, modify the code, and also come up with other formats of solutions. So basically, the idea is like this. So now let's do a check. Yeah, it passes the first example. Now let's look at its final state. So let's do this. So this one we should return 1, right? So let's do another one. Let's see. We have 2, 2. So this should give us 0. Now let's look at the generic case. Yeah, so it passes the generic case. So it did it a very long time ago. Yeah. So anyway, so that's about it for this problem. So let me give a quick summary. So in this problem is an easy problem marked by leetcode. However, it's very interesting. So here we are solving this problem using or with the help of data structures or data type. So here we are using heap, right? So also actually when we do the coding, it's important to notice the constraints or additional assumptions. Sometimes it can give us hint on how to do the problem or how to do the coding, or if we need to use extra effort to improve the coding or the code. So with that said, that's about it for this video. Thank you.